Hey guys, welcome to a video on solving differential equations. A differential equation is an equation that relates one or more functions and their derivatives. So here what I have is y equals x squared plus 2. Maybe that's this person here. Okay. Y equals x squared plus 1. Maybe that's this person right here. Y equals x squared minus 2. Maybe that's like down here somewhere, and so on. So we have these parabolas, okay? And these are actually what we call specific or particular solutions to each one of these, okay? So if I try to integrate 2x, we all know that the integral of 2x is x squared, but it's also going to have a plus c because we don't know where it passes through. Well, how do I solve this if I give you the point that's on the curve? How do I solve that? Well, on your calculus BC exam or AB, you're going to have to do 5 to 6 steps to get 5 or 6 points. So in this problem here, I ask solve the differential equation with initial condition f of 2 equals 5. What I need to do first is make sure that I separate the variables, but before I do that, I need to rewrite y prime to be dy dx equals x plus 3. Then I need to, step 1, separate the variables. Now on the AP, if you don't separate the variables, you get 0 out of 6. So that has to be your first step. What I mean by separate the variables is you make all the y's on the left side and all the x's on the right side. So I'm going to put the dx on this side. You must cross multiply and put the dx here. So now I have dy on one side, and you could actually put a 1 in front of it, and dx on the other side. Step 2 is to integrate 1 dy and integrate x plus 3 dx. So we integrate who gives me 1, y. Who gives me x? X squared over 2. Who gives me 3? 3x plus c. So this right here is the integral, and you get 3 points up to right to this point. Now, what we're going to have to do, so this is step 3, is that you integrate it properly. Okay, so you got to separate the variables and then integrate. Now you're going to use your initial condition, or the condition that was given to you. So this part is your y, this part is your x. So I'm going to go 5 equals x squared over 2 plus, so y equals, so y is 5, x is 2, so 2 squared over 2 plus 3 times 2 plus c. 5 equals 2 squared is 4 over 2 is 2 plus 6 plus c, that's 8. So c is equal to -3. So what we have to do is now take this -3 and resubstitute it back into step 3. So I don't want to go off to a different page. So what I'm going to do here is I'm going to write x squared over 2 plus 3x minus 3. Now that y is by itself, you are done. And if you were to graph this parabola, you would know that it would pass through the point 2, 5. So that's pretty much it for solving differential equations. Okay, let's try another example. Okay, solve the differential equation. It goes through the point pi over 2, 2. Step 1 is to separate the variables. So it's basically putting this right here, x's with x's, y's with y's. You are not to do 2 steps in one. Step 2 is to integrate. And you ask yourself, who gives me 1 dy? That's y. And who gives me cosine? Sine. Now, you're going to have to solve for c. Okay, and we're going to make this our x and this is our y. So 2 equals sine pi over 2 plus c. 2 equals 1 plus c. C is equal to 1. You have to take this back into step 3. So y equals sine x plus 1. Since y is by itself, you are done. So it's basically just integrating and then substituting a point to solve for c, and then going back and making sure y is solved for, okay? So let's take a look here. Now I did this one out for you guys already, so we don't have to waste time, but let's solve the differential equation of dy dx equals x divided by y. Here's our point that it's going to pass through. Step 1 is to make sure the y's are on the same side. So I'm going to bring the y here. It's like cross multiplying, and the dx here. You cannot do the problem and you will get 0 credit if you don't separate the variables. So we separate the variables, then we integrate. So what's the integral of y? You add 1 to the exponent, divide by the exponent. What's the integral of x? You add 1 to the exponent, divide by the exponent, plus c. You are not to do anything about simplifying, cleaning up, or anything until you solve for c. So what I did here was I plugged 2 for x, negative 4 for y. I got negative 4 squared is 16 over 2 is 8. 2 squared over 2 is going to be 2. C is equal to 6. Once you get c equal to 6, you got to plug it right back in here. So take a look here. I got c to be 6, and I plugged it back in here. So we're right here. Okay, always go back to step 3. Now, this answer is not acceptable because y is not acceptable because y is not isolated. So I'm going to multiply everything out by 2. So this 2 hits this 2, it cancels out. This 2 hits this 2, it cancels out. This 2 hits this 6, and there's a 12. You're going to now have to take the square root. So I took the square root on both sides. And there's one huge problem. So on the BC exam, you got to make sure that, especially for this, when you take the square root, that you pick the right sign. So it's either going to be positive or negative. That's going to depend on passing through the initial condition. The initial condition is 2, negative 4. Because the y is negative, this is going to be a negative. Think about it. It has to pass through the point 2, negative 4. If you plug 2 in here, 2 squared is 4, right? 4 plus 16 is 4 plus 12 is 16. The square root of 16 is positive 4. So since I have a negative 4, I must put a negative there. You can pause the video and rewatch and take your time with it. But be very careful because these are 6-point problems. Next one I'm going to do with you. Leave the 5x by itself. Always leave the constant on the right side. Divide the y and bring the dx over to this side. So dy over y equals 5x dx. Then you're going to integrate both sides, right? So this is step 1 and 2 together. The integral of 1 over y is the natural log of y. The integral of 5x is going to be 5x squared over 2 plus c. It's going to pass through the point 0, 1. So natural log of 1 equals 5 times 0 squared over 2 plus c. Natural log of 1 is 0, and that's going to be 0 plus c, so c is just 0. Great. You plug that back in to step 3, which is basically plugging in nothing. And how do we get rid of a natural log? Well, we raise the other side to an e. So y equals e to the other side. And then you are finished. You cannot leave it in this format because it's not y by itself. Okay? So you can pause the video and so on. So I hope all of this makes sense. All you're doing is integrating, but you can't integrate until you separate the variables. The y's got to be on the left and the x is on the right. So I'm going to do another one with you right here. I'm going to bring this over. I'm sure you guys got the hang of it by now, but some of them get a little tricky, so you got to be very careful. You should watch the whole video. So the integral of 1 dy is y. The integral of e to an exponent is going to be e to the exponent divided by the derivative of the exponent, or you can do a u sub. So there's a third. The derivative of 3x is 3, so you got to divide by 3. You're going to plug in the initial condition. X is 0, y is 3. Remember, e to the 0 power is 1. Okay, so I picked a ugly number, but that's fine. Minus, right? So that's going to be 9/8. Okay, so that's your C. And then you're going to go back and plug it in here into step 3. Okay, and then we're good to go. Or you can go e to the 3x plus 8 over 3 is equal to y. Okay, I believe I have 2 more, so stay with me on this. I did this one out for you, so this is one of the most important ones. Okay, it has to pass through the 5, -1. It's y plus 2. You are not allowed to subtract 2 on both sides. That's illegal. You are not allowed to subtract y. These are stuck together, okay? You can only divide or multiply. You can't do anything else when you are doing these problems. So I'm going to divide the whole piece. So we know to bring dx to this side. So that's why it's here. And then I'm going to divide by y plus 2. I'm going to integrate this. Anytime your variable is to the first power and it's in the denominator and you are integrating, it's a natural log. The integral of 1 over y plus 2 is the natural log of y plus 2. The integral of 1 dx is 1x plus c. You are going to now plug in x to be 5 and -1 to be y. So once again, natural log of 1 is 0 after you plug in -1, 5. And you get 5 plus what number makes 0? -5. So c is -5, and you plug it back into step 3. So you get to this point here. You have to raise this part. So e raised to this. And then you minus 2. So I hope you guys can see that. You got y by itself. Okay? So all you're doing is integrating plus c and then filling it in. But the point is, if you do not separate the variables first, you will not get credit whatsoever. So I'm going to keep x here. I'm going to bring y down here. I'm going to bring dx up here. So take a look at this. Step 1, separate the variables. Step 2, integrate. Because this is y to the first, it's natural log. Because this is x to the first, it's natural log. I picked this point e squared and e. E squared is your x. E is your y. I want you guys to remember when natural log touches e, it leaves you with the exponent. So that's a 1. When natural log touches e, it leaves you with the exponent. So that's a 2. So we got c to be -1. That's not your answer. You got to go back to step 3, plug it in. So here I plugged it in. Okay. And now what I'm going to do is I'm going to raise this side to e, right? Just like this. Raise that side to e. That's how you get rid of the natural log. And I want you to remember that you can rewrite e of natural log of x minus 1 as e of natural log of x times e of -1. Because the bases are the same, you just add the exponents. So you can also do it in reverse. When e touches natural log, you're left with the exponent. So these are just alternate ways of writing it. As long as your y is by itself, you are good to go. And then I just did this for you. I said, imagine we ended up getting this as our final answer. If you look at the AP free response solutions, you're going to see that a lot of times when you have e to an exponent like this, the e to the natural log of 5, or in this case, natural log of 5, will just leave you with a 5. So what you want to do is you want to keep the variables together, and when you see e touching a natural log, you can separate them to put the 5 there. So that's what I would do. So take your time, take a look at this, pause the video, and I hope this helped.